question. So now, guys, let's move to question 9.3. Okay, so let's check what the question says. So the question says, if device R delivers power of 12 watts, calculate the reading on ammeter 2. Okay, so they're saying if this device R delivers power of 12 watts. So let's see if it delivers power of 12 watts. Okay, then calculate the reading on ammeter A2. So guys, for the fact that we're given a power there, we might need to know the formula for calculating power, because at some point it might assist us to calculate what the question wants. So I'm just quickly going to check the formula sheet, okay, and look for that formula for calculating the power. You've got a lot of formulas of which you need to be careful of which formula to use. So these are the formulas that we use when it comes to the circuits. Can you see? So I think it would be best to just go for the simplest formula. You might, in some cases, need to use a different formula. And again, also for this question, you might do it differently, but I just want to show you the simplest way of doing it. So there you've got P, which is equals to VI. So we've got P, which is equals to VI. Okay, so guys, let's see. Have we got the power? We do have the power. They said is 12 watts, okay, which is equals to the V. Have we got the V of R? We don't have that V of R. And obviously I, it's what we want to calculate. I of ammeter 2. I think that's what the question said. Let me just quickly check so that we are 100% sure. Okay, there's the question. The question says, if device R delivers power of 12 watts, calculate the reading on ammeter 2. So this question is almost the same as that one. So that's why our approach might also be the same. Okay, so guys, let me see. I'm just trying to think of the easiest way of approaching this question. Okay, but let's see. We can calculate a V on that 20 ohms resistor. Okay, remember we've got a V for this branch. Okay, so if we calculate, if we combine the voltage of these two resistors, okay, so we can still apply the same rule where the V of this combination will be the same as the V of R. I'm not sure if you remember, guys. You remember we said if we've got a connection, this is R and then this is R, a resistor. We said if we can have V there, okay? So this V is the same as that V, right? I hope you remember. So let me just quickly explain to you what I'm thinking so that you are able to follow. So what I'm saying is, now that we know, remember this is that parallel combination. What if this parallel combination, we combine it, and then from there we combine it with that one, then we just have one, and then from there what we do, this is A, what we do, we then calculate this V. As soon as we have this V, we know that V is the same as that V. Then we can just substitute that V there, then we'll be able to calculate the current through the 2 ohms resistor. I think this will work, guys. let's just give it a try and see how far we can go with that. So let's see, we've got that V there is 12. Let's try to calculate V there. Okay, so that means V at 20 ohms resistor, we know V is equals to IR, right? So what is the current flowing there? Obviously we've calculated it, it's 0.75, right? It's 0.75. What is the R there? It's 20. Then let's see, it's 0.75 times 20, it's equals to 15. So it's equals to 15 volts. So that means we've got V there, we've got A1, we've got V there, then we've got that R, we've got that ammeter 2, ammeter 2. Okay, so we know, guys, that V there, we just calculated it, isn't it? How much was it? It was 4V. Can you see there? That V, it was 4V, right? We just calculated this V now. It's 15V. Okay, so what I'm saying, guys, what I'm saying is, if we sum these two V's, then it means we just have one resistor there with just one V. Then what will be that V? Obviously 14 plus 15, which is going to be 19V. So that means that 19V across this one resistor is the same as the V across that R. I'm not sure if you fully understand, guys, but this is what we've done on question 9.2. I think if you can just try to replay this video over and over again, you will be able to have a full understanding. So let's see, this is the V, so that means we can say V total is equals to, obviously this will be 4 plus 15 volts. This is that 4 volts plus 15 volts, okay, which is equals to 19 volts, right? So now we can substitute into that formula, which is P is equals to V I. So we know power is equals to 12. Okay, we're given that power as 12 watts, which is equals to V, we just calculated V multiplied by the current flowing through ammeter 2. Okay, so that means the reading on ammeter 2, which is I, is equals to 12 divided by 19. Let's see, 12 divided by 19, it's equals to 0.63. I'm sure you also get the same answer when you punch on a calculator at 0.63 amperes. Okay, so this is the reading on ammeter 2. So guys, that's how you answer this question. Okay, so this question, it's as easy as it is, guys. Now I'm just quickly going to show you where you score some marks on this question. And remember, I think this question was allocated 5 marks. Okay, so guys, let's see, where do you score your first mark? They'll obviously give you the first mark there for writing that formula, and again for you to calculate that V, they're going to give you a mark, and again they also give you a mark for that formula. Obviously, you know, after the formula they give you a mark for correct substitution, and obviously your last mark will come from your final answer with the correct SI unit. So the unit for current, it's amperes. So you shouldn't write 0.63, but it should be 0.63 amperes. Okay, so guys, that's how you solve for question 9.3. So in terms of the current, guys, in terms of the current, that means the current flowing there, it's 0.63 amperes. Okay, so let's just do some comparisons, guys. Let's just do some comparisons. Can you see there on that branch? Okay, we've got 16 ohms resistor, we've got 8 ohms resistor, you've got 0.5 amperes, you've got 0.25 amperes. So can you see more current is flowing through that resistor which has less resistance, okay, and less resistance flows through that current which has more resistance, okay. So now you've got the combination of these two resistors, which is 0.75. So that means the current which is being shared amongst these two resistors is 0.75. So that means as the current flows there, it's sharing that 0.75. So a part of it will flow through that side, a part of it will go through that side, and when it gets to that point, is the combination of these two currents, then it's 0.75. So when it gets there, and obviously from that side, when it gets there, it combines, it joins, okay. So that means the current flowing there is the combination of these two currents. I'm not sure if you understand, guys. So for example, there you've got two currents. When you combine these two currents, they give you the current flowing there, okay. So this current flowing there, as it joins with that current flowing from that side, when it gets to that point, it combines. Think of it as water flowing from that pipe, another water flowing from that pipe. When it gets to that point, it joins, and then it means you've got this amount of water and this amount of water. So that means current flowing there, it's equals to that 0.75 plus 0.63 amperes. So this is the current total, or the current external. Okay, so that's what we talk about when we say the external, or the current flowing through the external circuit. So everything here was flowing through the parallel connection, even though within this parallel you still have a branch there. So now you've got this current flowing through the external resistance, and it also, the same current flowing externally is the same current passing internally through that internal system, or through that battery, okay. So that same current, so that means, in short, guys, let's just check what is I'm not sure if, you know, when your calculator gives you some problems, you just have to hit it hard. I'm not sure if, okay, now it's working. So guys, let's see, just say 0.75, okay, then plus 0.63, this is 1.33, okay. So that means this is 1.33 amperes, okay. So what I'm saying, guys, is that the current flowing on that black wire, okay, it's 1.33, okay. So guys, let's now move to the next question. Maybe you'll have a better understanding when we move to the next question, okay. So I'm just going to wipe all of this. So guys, I'm not really sure if I picked a difficult question, but you know, when we do these difficult questions, you are able to see that, okay, questions may be as difficult